Welcome. I'm sorry about the technical problems before starting. I hope this works now. It's my pleasure to welcome you all and our panelists to our webinar. It's the first one out of a series of webinars which we call Insights and Perspectives on the Mitigation of Shortlist Climate-Forcing Pollutants, which is facilitated by the Interdisciplinary and Global Working Group on Shortlist Climate-Forcing Pollutants. And today's topic will be the complexity of cleaner cookstoves, and I'm very happy to present our very select group of panelists here. I would also like to let you know that we have a variety of audiences joining us. We have you, the live audience here in Potsdam. We have a virtual audience who joined us via a web conference system. Hello there. And there is also an audience who is following this discussion via the internet, via the live stream we're broadcasting. So now I have the pleasure to introduce you to the panelists. I will start with the ones who are joining us by calling in from the field and actually made quite big efforts to be here with us today. There is Dean Still, the Executive Director of Approvecho Research. He's calling in from Oregon. Approvecho is one of the oldest stove design and research centers and has been involved with groups around the world in various cultural contexts to build capacity for stove design and testing. We also have Moshin Sarar. He is a stove designer himself and founder and director of Prakti Design Lab. And he's calling in from Nepal today. And Prakti is focusing on designing biomass stoves, and they work in Haiti, Nepal, and many African cities, in addition to South Asia. And Prakti uses an integrative approach that tries to fully involve the users while bringing state-of-the-art engineering into the kitchen. Now, I'm also very happy to have three panelists here in Potsdam. So to my left is Professor Ramanathan. He's an atmospheric and climate scientist at the Scripps Institution of Oceanography in San Diego, United States. And he's also the initiator of the Surya project, which is a large-scale field experiment in India that intends to demonstrate the health and climate gains from moving towards cleaner cookstoves. Next to him is Mark Lawrence. He's also an atmospheric scientist and also the scientific director of this institution here, the Institute for Advanced Sustainability Studies. And he is leading a research cluster on sustainable interactions with the atmosphere. And one of his driving research questions at the moment is what options are there in addition to CO2 emission reduction for taking rapid action against global warming. And last, but definitely not least, I would like to introduce Maheshwar Rupaketi. He's an atmospheric scientist also here at the Institute for Advanced Sustainability Studies. And he has worked formerly for the UNEP program Atmospheric Brown Clouds and is now leading a 4-year project which is called A Sustainable Atmosphere for the Kathmandu Valley in Nepal. And this study involves both field measurements but also the formulation of policy recommendations. So thank you all for joining us today. And now before we start, I would like to just take 1 minute to give you a brief introduction to the topic. So cleaner cookstoves have often been presented as a simple solution for an important public health and climate challenge. And that means the technology exists, the needs are established, and the costs are relatively low. However, implementation, and by implementation I mean creating the enabling conditions for hundreds of millions of people to have access to cleaner burning stoves, has proved much more difficult or challenging than thought before. And these challenges have still not been overcome yet, even though the respective initiatives have gained quite considerable momentum. And this is why we're discussing this today. Just to give you an idea, we will first focus on problems and solutions, then have a round of open discussion, and then towards the end we would like to stress how we can better work together across the different fields of science and practice. Okay, so the first question, focusing on the problem. Could each one of you discuss your findings and experience with the impact of traditional cook stoves on either the socio-economic development, climate science, air pollution, and public health, depending on your background and your experience? And may I direct this question first to Professor Ramanathan?
Thank you, Julia.
Good afternoon from Potsdam. I am visiting this institute. I wanted to congratulate this institute, which is it's a new innovative institute working on the intersection between science, technology, society, and environment. And the problem we're going to discuss is one such problem. Roughly about 2.5 billion, probably more, are still relying on traditional, what we call biomass fuels, such as firewood, cow dung, and crop waste, to meet their basic energy needs. Perhaps one of the most basic energy need is cooking. And before we discuss this problem, we have to be clear that the people who use these stoves or this biomass are pretty much forced by either they cannot afford modern fossil fuels or they have no access to it. In a sense, it's a basic failure of our society to have left behind roughly 40% of the population. And as the world's population is going to increase from 7 to perhaps 9 billion, it's likely more of the increase we would see in this society we are left behind. So this is centuries old problem. But there are three important developments which has propelled us to the front page, to the extent that we see a solution not in the too distant future. The first is the health effects of this cooking with traditional biomass. We all know when you burn firewood or cow dung, smoke comes out. And the smoke has numerous pollutants, gases and particles, and we call them aerosols in our jargon. Inhalation of this toxic smoke has now been shown by numerous studies, particularly and evaluated by bodies such as the World Health Organization, to be causing millions of lives' death, particularly amongst women and children. Okay, so we now know we cannot let premature deaths like these in modern society. The second, which could become a game changer, is that science done in the last 10 years have shown convincingly that this smoke contains major climate-changing pollutants. First, of course, we have to know when you clear forests, growing forests for firewood, you lead to more increase in carbon dioxide, the most deadly climate warming pollutant that we know of. Okay? In addition to that, the smoke contains a particle we call them soot or black carbon. That's what gives the darkish color to the smoke. It's dark because it absorbs enormous amount of sunlight. And this absorption of sunlight by the smoke, when it gets into the air, heats the air and contributes to global warming, melting of the glaciers, such as in the Himalayas and other regions. It also contains other gases like methane, which is the global warming gases, and some pollutants which lead to another toxic pollutant like ozone, which my colleague Dr. Mark Lawrence, one of the directors of this institute, would talk about. So why is this such a game changer? We know the world has recognized climate change is the most important problem, one of the most important problems facing societies, and to mitigate climate change, there are a huge number of funds being released through carbon credits and as well as in the so-called voluntary carbon market. So our goal in this Project Surya is if we can actually intervene, replacing them with newer cookstoves, then if we can document how much global warming can be mitigated, and there is hope that some of the carbon credit funds could go directly to the women who are using these stoves. So it provides one more incentive. And the last development I want to say, which we'll hear from our other colleagues, particularly Mohsin and Dr. Dean Still, is that there are now new technologies available which tell us that it's possible to still use this biomass, after all it's renewable, and provided that deforestation doesn't happen, that we can cut down these emissions that lead to CO2 as well as all these pollutants. So major problems are there, the solution seems to be there. And just I want to conclude with one statement of why I think we are so close to solving this problem, is that recognizing the Secretary of State Hillary Clinton early last year has formed this global coalition for cookstoves. This alliance is put within the UN Foundation. So now the problems are clear, the solution may be done when soon, and there's global recognition. Thank you.
Okay, thank you very much for that. And Mohsin, may I ask you the same question? Could you report a little bit on how you see the problem of implementing newer cookstoves from your experience?
Sure. To comment first on this question of the complexity of cleaner cookstoves. I think when we say the complexity, it's very relative. If we do it with the right process, with the right tools, it is not complex. If we try to cut corners, then it is complex. To be a little bit more specific, what we learned to the last 8 years that I've been involved in stoves is to have an impact, to have an actual solution that's sustainable and scalable, is you must have a stove enterprise doing the design, the engineering, the production, and distribution. So just kind of to clarify my view, my focus is on the dissemination, the implementation on stoves, rather than the research. So that's when I'm talking about the complexity of stoves, I'm talking about the actual dissemination of the stove. So so it has been is a big challenge to can we set up these stove enterprises that can have be active on all these elements, design, production, and distribution, and can they have all the resources they need to do their work? This is the first level. I think what is the biggest challenge, in my opinion, for to have a scalable impact of stoves. The other challenges that we face from a technical point of view, burning biomass is technically extremely challenging. The second element is the customization. With stoves, you cannot have one stove, develop one stove, and expect that this stove is good for many regions. Stoves must be customized. And for us, the challenge was to develop a design, methodology, production process, a marketing process where we can customize the stove that we offer to the different regions where we operate. Lastly, the biggest challenge is that it takes time. It takes years to understand what kind of stove do people want in specific regions. What kind of stoves they want. What can we offer them in terms of the design, the performance, the usability, the costing? What's the most effective way to do the marketing of the stores for this specific region? What kind of financing we offer to the user? So this has been the challenges for us.
Okay, thank you, Machine. Just to summarize, I don't know how the audio has been here, so the four biggest problems that Machine was mentioning was one, that the engineering and implementation and dissemination as such is a challenge. From a technical point of view, burning biomass is also not easy. And then also they have to customize the stoves. There is not one solution for everyone. And with that, of course, it takes time. So it's a question of years to develop the right stoves for the right community. Mark, may I ask you this question?
So good afternoon, everybody. I'd like to talk first a little bit about the impacts of Cookstoves, which is the perspective that I can bring in better. And I'd like to go back a little ways in history to about 15 years ago when my colleague Ramanathan was spearheading the development of a major field experiment together with Paul Crutzen, and I had the privilege of being involved in that. And the experiment was called the Indian Ocean Experiment, or INDOX. And in INDOX, we had several campaigns, several years of measurements building up to the main campaign, which was in 1999. And what we discovered was that in the wintertime, you could measure an enormous cloud, a brown cloud of pollution, extending out southwards from the Indian Peninsula all the way down to about the equator. So over 1,000 or even more kilometers, you had pollution at levels that were typical of polluted cities in Europe or North America, way out over the ocean. And you could see the transition from the southern hemisphere to the northern hemisphere very clearly. Within a few hundred kilometers, you would triple or more your pollution levels of things like carbon monoxide. So this was looked at carefully, and the question was, where was this pollution coming from? And there was a raging debate about this at first. And the initial indications from some was that it was mostly from fossil fuel burning, that this was all coming from the two-stroke engines and other heavy polluters in India. But several others were showing that it appeared to be coming from biofuel burning, which would be indicative especially of the cookstoves. And the debate went on for many years, and it was finally pretty much resolved just a couple of years ago with a study that looked at isotope analysis, and they found that it's about 50-50. About half of this pollution is coming from biofuel burning that's extending out over this massive region. Well, at first, this pollution, it was called a brown cloud, and at first the mistake was made to give it the name the Asian brown cloud. And Ram will remember this very well, that at the time that was picked up very, very quickly and didn't go over very well. And this is part of the point that I want to bring out about the care in the discussion of these topics and in the sense of placing blame. And there were a number of people who were very sensitive and thought that the Westerners were coming in and placing blame on India for causing a substantial warming to the atmosphere through this pollution. Well, the name was very quickly changed to the atmospheric brown cloud, And UNEP, United Nations Environmental Program, picked this up and started up a program called the Atmospheric Brown Cloud ABC program. So where I'd like to draw this into the next step of the implementation of cleaner cookstoves, part of the reason that people would want to implement cleaner cookstoves is so that they have cleaner indoor air. And part of the reason is so that they have cleaner outdoor air. So it would reduce the outdoor pollution in the villages. And of course, it's much more convincing if you can see an effect directly in the village where all this implementation is going on. And another small debate, not quite the same raging debate as before, but Ramanathan and I have been considering for a while how much of what you might call a black carbon hole would you actually see if you were to be able to replace all of the cookstoves within a single village with clean cookstoves. And this is something that we're still looking into ways to discover and to try to figure out what kind of effect we would see. We have varying opinions on this, from the idea that you would see pretty much a black carbon hole, a very, very strong reduction of black carbon, of soot and other pollutants directly in the village, to an impression on the other side based on this large outflow that if the pollution is spreading around so much that there's a high likelihood that the air in a single village is being strongly impacted by the air from upstream villages. And so we've been making steps forward on solving this, but I think the real solution is not going to come from computer models, and it's probably not even going to come from the types of proxy measurements that Ram and I have been talking about, but it's going to come from a real implementation. And I hope that we will have a major implementation in the near future where we can actually see those kinds of impacts and have an idea also then what kind of impact this would have on the larger scale.
Okay, thank you. Dean,
Dean,
may I ask you to
you
answer the question from your experience? Where do you see the problems with large-scale implementation of cleaner cookstoves?
To count up the problems, but let me start with the happy news. I think that there's been a lot of progress made in the last 3 years trying to figure out how can we make a $5 combustion chamber that will decrease the black carbon, addressing both the indoor air pollution and the effects on climate. 3 years ago, we didn't understand what makes black particulate matter versus blonde or white, and now we do. So I think the technical problems are being addressed, and the production of those combustion chambers is starting up. The mass production in China and other countries. I think, first of all, from my side, the more technical, the stove side, that was the part that we really had to address first. To understand how does one decrease these emissions. And like I say, I think we're getting a lot closer to understanding, and not just understanding it in a theoretical way, but how does one make it for an affordable price? Just like Musin says, the stove I see as being designed by the user, but I imagine that the combustion chamber could be then installed in many different applications so that dissemination, hopefully by purchasing stoves that are at a market price, can happen a lot easier. So in a nutshell, I think the technical problems are being solved. The manufacturing is relatively easy, especially in China, where there are huge factories right now that are making stoves in the millions for China. So they're already ready to go, to make the new technologies. And then involving the cooks, the users, in making the appropriate application.
Okay. Thank you, Dean. So the last one in the round would be Maheshwar. May I ask you to answer the question?
Yep. Okay. Thank you, Yulia. Good afternoon, everyone. Let me start with my own experience. I spent most of my childhood in my mom's, very smoky kitchen. That was almost, 3 decades ago. And, last December, out of my own interest, we made some measurements of black carbon and, particulate matter in the same kitchen where I used to be, 35 years ago. And we found that the PM 2.5 level is still, 5 to 6 times higher than WHO standard. And the black carbon is somewhere around, 50 microgram per cubic meter, which is, WHO standard for, 24 hours for the whole, total PM 2.5. At the same time, we have been, in a way, fortunate to have a biogas digester that's fully functioning for the last 10 years without any problem. So for me, that shows a real picture of the problem. We do have the problem like a smoky kitchen, and we already have some solutions that are working in the field. And then we do have, problems of, getting those solutions adapted widely. Even in a case like my own, house, we still use traditional cookie stove versus the clean solutions like biogas, digesters. So why this hasn't been widely adopted, though, I can comment on these, for next few minutes. If I take biogas program as one of the most successful programs in Nepal, it has penetrated wide range of communities, serving, more than 200,000 households now. So basically, what I see is there is a problem related to health and other, socioeconomic problem associated with these pollutants. And whether we call the challenges, obstacles, opportunities, whatever we call, looking at the past, the programs, if I can summarize, that revolve around 6 issues. The technology design, that Dean just mentioned, that's being addressed largely. And then, the customers you are targeting, what type of customers that you are targeting, where they fall in the wide spectrum of the communities or the families. And then financial, arrangements, whether it's upfront, support for the entrepreneurs, or it's the finance from the user side. That plays a major role. And also the market arrangements, how these clean technologies are being marketed. And then it's not only the market, how well these the solutions are channeled. Basically the channeling strategies, which group, where, when, how, that sort of channeling arrangements. And then last but not least, what sort of institutions are involved in promoting these clean solutions, whether it's not-for-profit organization or private organizations or government institutions. So if you look around these 6 issues, so you will find most of the challenges, barriers, opportunities And if we address them properly, especially customizing to the local need, then I think we can scale them up for a large scale. Thank you.
Thank you, Mahendra, for these insights. Could you turn off your microphone? Okay, thank you for these insights. Now, we have started, or we wanted to start by characterizing the problem. Now, I heard a number of solutions. It seems that actually large-scale implementation isn't too far away from now. You have mentioned that the technical problems are largely overcome, that the question of customizing the stoves, including the users, giving them a stakeholder voice in it and helping them to design the stoves helps very much, and mass production in China is going on. So now the question is, are we right now at a moment in time where we can start large-scale dissemination and be sure that this will work? Or where do you see the biggest obstacles and challenges that have yet to be overcome to move more people to the usage of cleaner cook stoves? And I would like to address this question first to Dean.
Well, I think that we need to be rational in our approach, that the new technologies, which remember, the stove is the heart of the home. In many countries, the stove has deep religious meanings to the family, to the cook. So this stove, you know, like you were saying, let's say that it has the clean combustion chamber in it, but the cook very much has, you know, it has to cook a chapati, it has to cook a tortilla, it has to cook spaghetti somewhere else. So the application will change. Then I think, just like Dr. Ramanathan is doing now, we do pilot studies looking at the actual effect in use. Because it's one thing in a laboratory, it's another thing in use. And we learn from those studies, how do we have people turn to the new technology and not use the dirty technology at the same time in the same kitchen? And that's something that is going to be very important for the success of, you know, turning this problem around. And so I think that this is where the Global Alliance is headed. This is where scientific investigation is headed, that we're now, you know, getting a supply of these super clean stoves available to scientists who can then go around the world, do pilot studies, and determine how does real adoption best take place.
Okay, thank you, Dean. May I ask Professor Ramanathan to answer to this?
Dean said, but I wanted to share some experience from our field work, both making the measurements from the stoves and trying new technologies in Kenya and in India. Women invariably, almost always, very much like the improved technologies. We haven't found this religious attribution to the mud stoves. So that's the first point I want to make, because they are all aware the smoke is insidious. It is very interesting in the North Indian villages. They even know about the brown clouds, and they know what it's doing to the outside environment. But this way I want to share my personal experience. The reason women don't really use these stoves as much as we like them to is the technology is not up to mark. I know I'm making a controversial statement. I'll give you a few examples. First, we have to recognize there are three types of stoves which are being tried. One is the biomass stoves. That's what we've been talking about. And Mahesh Rupika talked about biogas stoves. That is, instead of burning the cow dung as cow dung cakes, you convert them into gas, methane, and then that burn. Third, we have not talked about the solar stoves. It just concentrates sunlight. So all three are being tried out. So focusing on the biomass stoves, one of the best stoves is not only improved combustion chamber, but it also has a fan. As you know, you produce black carbon and soot because of lack of oxygen. So the fan is another $5 solution. But all these stoves are single burner. And that, to me, is where the problem, one of the problem lies, because the mud stove provides 2 burners, and you need minimum 2 burners to do cooking. All of us need 2 burners. So first is the convenience is not there. The second, in northern climates, in the wintertime, the traditional mud stove also acts like fireplace. It provides heat. So these improved technologies cut one of the most important source of energy for them, heating. So we found in our villages, they used our stoves throughout the year. In fact, in one village, still about 60% is being used. But in the wintertime, they burn the traditional mud stove too, to provide the heat. So we can't think of it as a purely energy efficiency issue. We have to think about the whole ensemble of issues, heating, lighting, and cooking. And I think once we do that, we'll find much, much improved adoption.
Okay. Thank you very much. Now, Mushin, may I ask your experience with what are the biggest challenges we're facing?
So, we sell stoves, and that put us in an interesting position. Is when we go to the customer and we want him to buy our stove. The key thing is that what he's paying for, is it worth the value that I'm giving him, or in this case, giving her. So very important to realize that a cook woman will never buy our stove because it reduces black carbon by 90%. They have their own values, and from working in different countries, we learned like one, how can we give value to the stove? What is the most important is the aspiration. Is it a stove that they will be proud owning? Is it shiny? Is it a color that they like? Is it a color that will remain shiny even in their very dark kitchen? Other aspect is speed. Very, very important. Speed and usability. Is the stove that we give them will make their life easier. Like Prof. Ramanathan mentioned, having a double burner is critical for places where they cook 2 things. Even if that stove will be maybe 50 more expensive than a single burner, for the user it's much higher value. So in this sense, what the key lesson is that we won't solve the problem by giving the cheapest stove possible, the cheapest solution. We need to give the best value that they can afford. And the last lesson learned is that and I will give it in the context of the story from Nepal. We had a very happy customer about using our chimney stove, and we assumed that's great. We assumed that she was very happy with the stove because our stove was great. But here's what we learned. In Nepal, smoking meat is critical. It's very important. Not only they love the taste of smoked meat, but it's the only way they can preserve meat. So in a traditional stove, they will have the meat hang over a string over the traditional stove and get smoked, and that would take about 4 to 5 days. Their challenge, the one big problem they had before, was not the stove itself, but the problem was that in one of those evenings, the husband will come drunk to the house, drunk and starving. So what he will do, he will eat that meat. And this is a real serious problem for them. So how did we solve the problem? Actually, we didn't solve it, but just by giving them a stove that has a chimney, a metal chimney, now they had the idea themselves to attach a smoking box to the chimney so that they can put the meat inside the box to be smoked. And now that the box is a metal box, they can put a lock around it. And they can sleep without worrying about the drunk husband to eat the meat. And here, the point I want to make here is that when you look at the stove is not just for cooking the food. There is in the household there are many elements related to stoves, and when we want to market the stove, we have to use every tool we have to add value to that stove. But we have never to forget this. With our stove, we are competing with many other things. People want to buy cell phones, they want to buy TVs. There are so many things they want to buy. So the summary of our lesson learned is that how can we give the maximum value, the value in the eyes of the cook, not in our eyes.
Okay. Thank you, Mushin, for that. I don't know if the audience could hear enough, or would you like a summary? Summary. Okay. So a very quick summary. The essential point that Mushin is raising is that the value of the stove is very critical. There is many appliances for a stove in households, also as Professor Ramanathan stressed. It's not only for cooking, and he told the story from an experience in Nepal that meat is smoked as well, and so a burner that would not offer this option to smoke the meat wouldn't serve, and it wouldn't be attractive, so people would not replace it in the households. And in addition to that, the stove needs to have a very high value in terms of traditions and what it serves in the household, because people will not buy it because they can do good for climate. They will buy it because it serves them in the household. Okay, Maheshwar, may I address this question to you?
Yeah, thank you. Again, I agree to what Dean has said and Professor Ramanathan has said. Basically, a customer wants a total solution. It's not just incrementally improved cooking stove. Whether it's for heating or lighting or smoking the meat. I know from my own experience from Nepal, there are many types of meals that you cannot cook with the improved cooking stove. You need traditional cooking stove to cook those meals. So basically, we should look at the issues from the demand side. Interestingly, what I found in the literature that those who were able to sell largest number of cooking stoves actually spend a couple of months in the village and studies what the tradition and practices are, and then came back to the lab and designed the cooking stove that actually meet their requirement. And they are selling the largest number of cooking stoves. So you can see that if you address the total solution issue, whether it is supply of the services or stoves, viable supply chain, or address their need, something like what type of stove is actually accepted or applicable in that particular household or particular village. So looking from the demand side, and then coming back to the lab and designing these stoves and again flowing them through the market, I think that would be more viable, and that would be likely to be more adapted by the customers. Thank you.
Mark, your opinion.
Thanks, Yulia. I'd like to talk about 3 challenges that I see. The first one is a challenge for science, in the sense of what I talked about before with this debate over how much of an impact will we see on a village scale if we were to replace the cookstoves within that village. And this is a challenge then for science to understand this so that we neither raise expectations too high, which then could end up backfiring if we convince policymakers and donors that will have a massive effect and we don't end up seeing it, but also that we don't shoot too low and give an indication that, well, maybe we'll see something, maybe not, and have a difficult time ever getting anywhere with policymakers and donors on that. The second challenge is for public relations. And again, this goes back to what I mentioned before about the Asian brown cloud, which was redubbed the atmospheric brown cloud. And I think it's very important that we be careful that we don't poison the interaction through an uncareful pointing of fingers and laying too much blame on people who have difficult access to energy for using cook stoves that end up contributing substantially to the warming issue in the region. And I think it's important in that sense to point out that wood burning, although we tend to think of it as a problem over there, this is something that is something for Asia or for Africa, we should realize it's actually still a substantial problem in parts of Europe. And this is something that really became very clear a couple of years ago in a major field campaign in Paris, where we discovered in the wintertime, on many days, the peak pollution was not due to emissions from Paris. This big megacity in the middle of nowhere, basically, has pollution coming from around it, causing the largest pollution episodes. And that pollution coming from outside was mainly from the wood burning in chimneys. So wood burning is not only a problem in Asia, but in other parts of the world. However, I would like to definitely emphasize the pollution levels in Paris are much lower than what the poor people in many parts of India, Nepal, and other countries have to put up with. So I don't want to suggest that it's such a large problem, but it's a problem that does extend to other regions. So we should be very, very careful with the way that we frame things in the public relations to avoid placing blame, pointing fingers. And the final challenge is one that I can't say much about, but I think it's a really important one to bring out, which is a challenge for regulation and for law. And I think that we need to consider, of course, that there are differences in the development of law and regulation in developed countries, which are many of the ones that are advising what's going on in the development needs in the developing countries. And perhaps there's an opportunity for somebody, if there's anybody from the audience who has some expertise in this, if we open it up for discussion, that could bring in some points about the challenges for regulation and for law. But I think these are things that are not really brought in here that still need to be brought up in some aspect.
Okay, thank you very much for this view on the variety of challenges that we're still facing. Would any one of the panelists like to add something to this?
Well, this is Dean. I would like to add that Musin was when Shell Foundation wanted to figure out how could they make a commercial stove, the process that Musin directed in southern India was to go back and forth. I think it was 7 iterations of having women in villages, many villages in Tamil Nadu, 2 states, Karnataka in southern India, where the stove had to meet the clean standards, but then that prototype would go back to the villages. The women would use it. They would adopt it, evolve it to meet their needs. And so that process of this continual testing both in the field and in the lab, I think 7 different times back and forth, resulted in a stove that we, pretty well knew before we started disseminating them would be enjoyed by users and would be cleaner. So I think that how to do this has been explored and written about, and Dr. Sam Baldwin wrote a great book about this. And so I think we have a pattern for how to have clean stoves that meet users' needs, and now we just need to get to work on many levels and scientifically investigate what happens in reality. Dr. Kirk Smith has this famous saying: "You don't get what you expect; you get what you inspect," and that, I think, is now our challenge.
Okay. Thank you, Dean. And Professor Ramanathan has another comment to that.
I just want to conclude with some of the promising issues here, while we're focusing on the challenges and problems in terms of cutting down all the pollutant emissions, etc. We shouldn't forget 2 things. First, almost all the improved cookstoves, at least the ones we have tested, 6 of them, cut down fuel consumption significantly, somewhere between 10% to 50%. The second, they also save on cooking time. So both of them have immense benefits for the villagers who are depending on this already. And of course, if you use fuel consumption, you're already cutting down the pollution we are talking about. And on top of that is all the issues we are talking about, cutting down black carbon, cutting down other pollutants. So we are already a step ahead in terms of improving the socio-economic issues the women are facing, the health impacts they are facing with any one of these cookstoves.
Okay, thank you very much. And I think now it's time to move on to the second part of this session, where we have an open question and answer round. And I'm just wondering, now we have been talking about the many challenges we have. There are many solutions available, but now my question is, how can we establish the markets? Or what are exactly the channels that we need to create for large-scale implementation and dissemination of cookstoves? Does anyone of the panelists want to make a comment on that?
Well, sure. Again, this is Dean. I think that when we started out looking at stoves, and Aprovecho started in 1976, trying to make better stoves, we were thinking about creating factories and creating distribution networks. That kind of went out the window for us a while back, where now we are looking for established distribution networks and established factories where, you can imagine it's a lot easier instead of having to make a factory to just wander up to a factory that's already making stoves. You just change the design and bang, there you go. The same way to find national distribution chains, like just for example, in Mexico there was something called the Cono Supo, where in every little village there's a store that's the government assists, and so you can imagine that placing a stove, on those shelves is a fairly easy process, especially when the government realizes all of the associated, benefits, not just helping the woman to cook easier using less fuel, but also the health inside the home and addressing the climate change. So I would say that this is our this was a new thought for us. Is now we're just open and looking for both established factories and established distribution chains.
Okay, thank you very much, Dean. Is there questions from the live audience?
It's working.
It's working? Oh, okay. I was just wondering about one point about the implementation and deployment of these cookstoves. Given that there was a technological solution for all the aspects that were mentioned now in the panel, do you think that microfinancing instruments could play an important role for the deployment of these technologies, or is that only of minor relevance?
Okay, I'm repeating the question for Dean and Mushin on the telephone. So Thomas was asking if microfinancing would be a way to overcome the costs for the stove, so single families are able to invest into a new stove. Anyone from the panelists? Okay.
Hi, this is Mushin.
At least I can hear.
Mushin's trying to. Let Mushin do it first. It's easier.
Mushin, go first.
Oh, okay. So microfinancing is essential. But again, I think even we have to remember, we are making a product for the base of the pyramid. Even the base of the pyramid is a pyramid in itself. You have within the poor, there are the poor people who are using traditional stove that can afford to pay full price, without financing, and those that can't. And this is very important to do proper segmentation of the market. So microfinancing is very important, but there is even the top of the bottom of the pyramid that can afford to pay the price without financing. It is small, but it is there. Now, on the microfinancing, we have been knocking at doors of microfinancing organizations, and it is extremely, it is difficult for them. It is difficult because the stove, the amount of the cost of the stove is not high enough, or the overhead would be too high. But the most difficult part is that the people who are want to purchase the stove, they would not qualify for microfinancing. Microfinancing still so far exclusively focused on small entrepreneurs, on small entrepreneurs in the base of the pyramid. But your regular consumer, the regular cook, most of them would not qualify to get microloan. This is a challenge, but we see it for us as a challenge that we need. We are working, looking for ways to solve it. So microfinancing is needed today. As it is not working. So it is up to us to find the proper mechanism to microfinance.
Okay, thank you very much, Mushin. Just to summarize what he was saying, so microfinancing is needed, however it doesn't work because the individual cooks do not qualify for the system of microfinancing because the cost of a single cook stove is so low. And the overhead for this would be too high. So now it's up to the community to find smarter ways for covering these upfront costs or for facilitating these financings. I think Maheshwar is next. Yeah.
At least I can share one good example of microfinancing and then providing subsidies to the customers that has been quite successful in Nepal for the installation of biogas plants, biogas digesters. And then based upon the similar concept, combining microfinance and then subsidy and carbon credit. So, Nepal government is planning for, actually it has been launched, to install about 500,000 cook stoves over the next 5 years. So certainly we have to come up with a combination of different financing, schemes that will work out. That has worked out in the past, and that will certainly likely to work out that way. Thank you.
This is Ramanathan again. I just wanted to add to what Maheshwar said. While what we heard from Mushin may be true in the larger scale, the Energy Resources Institute in Delhi, India, whom we are working with in the Surya project, was working with the bank, government-run rural bank, who's just going to start giving microcredits to purchase of this improved stoves. And it'll just start in a month or so, about 1,000 stoves. And the interesting thing is the interest rate is not typical of microcredits, which runs into 20% or larger, more like traditional 8 to 10% rate. So slowly there is movement in the right direction in this.
Maheshwar?
I just want to add to that the problem with microfinancing is that it is unlikely to reach to the poorest of the poor. That has been a problem in many places because they are not actually able to pay back the loans, and because of that, many microfinancing institutions are not willing to go to that spectrum of the community. So we need to take that into account as well.
Dean, do you have anything to add to this question?
Again, I lived in a small village without a road in Mexico for 8 years, and eventually when they put in the road, the little Konosupo store I was describing, that was one of the first changes that happened, and suddenly there were goods on the shelf. And what families would do, although it's not microfinancing, they would see something on the shelf and it would stay there, and they would save up the money and purchase it. I think from my side, and I think as we mature the stove movement, it's to get the products inexpensive enough and working in every way that they are affordable to a large segment of biomass users. That's really what I'm working on, and always trying in every way, watching every penny to make it as affordable as possible, using the 100 different ways that business people do this, and then, of course, using all of the ways to make even the poorest of the poor be able to afford this new technology, remembering, as we've said, that the competition is free. You know, they already have an open fire. And so it does make it more of a challenge.
Okay, thank you very much. Now I think we take questions from the virtual audience.
Hello, everybody. I will try to represent the virtual audience, and there was one comment on your microfinance debate stating that microfinance does work, especially higher purchase works very good, and there's a lively discussion online on microfinancing and people getting in touch with each other. Then next, focusing on biomass stoves, on the type of fuel being used. There was a question about the costs and benefits from the large-scale movement to LPGs, to liquefied petroleum gas. Maybe someone from the panel or the audience could answer this question. Thank you.
Okay, would anyone like to take this question on not using biomass, but...
The question is about the LPG. Could you please clarify that question?
Yes, I think the question, as far as I understood, is what would be the value of moving towards LPG instead of using biomass?
Well,
you know, maybe I can share quickly my experience in Nepal. So in Nepal, what we are seeing is that people are using less, even those people who are using LPG instead of like the mix. Usually in every house you will find an LPG stove and a biomass stove. At least all the slums around in all the slums in Nepal. And what we are observing is that the cost of LPG is getting higher. The Nepali government is reducing subsidies, is putting restrictions on importing LPG to Nepal. So people are using more biomass now than a few years ago. So cost and access is a big challenge for LPG.
Okay, just summarizing, Mushin says that the cost of LPG is most likely too high, and also the accessibility to that type of fuel might not be given. So maybe I can expand on this question. So moving towards these clean cook stoves, does it mean that there will be a change in the type of fuel that has to be used? And if yes, will it be accessible and will it be affordable? Or are there other solutions to it? Maheshwar?
You know, if you put watery gas in your car, it won't run very well and it will make smoke. Of course, the fuel has to be dry enough to burn. I think that a good stove uses the fuel that the people have. And on the other hand, in a place that's well organized, in a country that's well organized, you can take advantage of the crop waste and pelletize that so that you get a very high end fuel, just like gasoline, that can be burned very well, very cleanly, even without a fan. So there are multiple approaches, but I do think that burning sticks is really what people do, and that our technologies should use found fuels as much as possible, and that always will be part of the solution, is at least to dry the sticks before you try to burn them.
Okay, thank you, Dean. Anyone else from the panel who would answer this? Okay. Then I think it's time to move on to the last section, where we speak a little bit more how we can work together across the different sectors of research and practice to make the large-scale implementation of Cookstoves go as smooth and quick as possible. So addressing this question to the Cookstove designers, how can Cookstove design profit from results from climate science and air pollution science and atmospheric science? Dean or Mushin, would anyone?
This is Mushin, and I will share a story that I think represents my experience as somebody who sells stoves or makes stoves. My experience working with the research. There was a very extensive health research project on stoves in India. Hundreds of stoves, maybe 50 different villages, extensive investment on looking at the impact, the health impact of stoves. And for this project, they was comparing the traditional stoves with the improved stoves. And the stoves that were picked for as improved stoves, there was the fan stove, single burner, and there were 3 rocket stoves, single burner also. I tried, the researchers asked for a stove for one of our stoves to include in their test. They asked for a single burner. We said, for India, people want double burner. Why don't you please test our double burner? And the answer was that we didn't understand that by having a double burner, we are going to make the statistical coefficient of variation too bad. So the point I want to make is that of the request for the academic research, that when research is done, it must be done in a very close partnership, coordination with the stove developers. Because not because we are smarter, but we are, by the nature of our work, we have to be very, very close to the customer. So please, when you want to do research, check with us what we think is important, what we think is not important.
Okay, thank you, Mushin, for that. I'll just briefly summarize again. So he is basically saying that when scientists would like to make research on this topic, it would be very worthwhile to collaborate very closely with the Cookstove designers, since they are very closely interconnected with the customers. So that would overarch all the stakeholders in this process. Dean, do you have anything to add to this from the point of view of a Cookstove designer?
Sure. It's just like the studies for health, and now there's a new international working agreement leading towards an ISO standard for stoves that is health-based. And so for researchers and designers, knowing what are the goals that the climate folks want us to try to achieve, to work closely as a team, where do you want is blonde okay for the particles, or do we need to go to white, or just for all of us to be more closely connected, know, just like as for health, we pretty much have goals. What are we supposed to be looking for in terms of clean combustion to address climate change?
Okay, thank you. Now, may I ask this question to the atmospheric scientists?
Yeah, I just wanted to share our experience in the Suya project, where we tried to bring in some of the air pollution and climate expertise into the cookstove issue. So we had sort of instrumented this one village, in fact, using novel cell phone technologies and some of the most sophisticated instruments. What we found, to our surprise, is that in these improved cookstoves, if you mix the fuels, it produces more pollution. For example, if you just firewood alone versus if you just use cow dung alone, the pollution that came out of that, up in terms of these particulates and black carbon, was a lot less than when you mix the two together, which is the practice in many of the homes. We saw they'll first start the fire with firewood and then put in the cow dung cakes. So that's one. So I think science has a lot to contribute in this. And the second thing we found was this natural draft stoves, which basically improve the combustion chamber, versus the so-called forced draft stoves. It takes the features of the improved combustion for the natural stove and then adds a fan. So we found all the forced draft stoves we tried. We didn't try too many, but 2 or 3 types. They brought down systematically the black carbon emission. I mean, particularly the black carbon concentration indoor came down significantly. But in the case of the natural draft stoves, some of them put out more pollution in terms of black carbon. They all reduce PM. So there are important insights we can gain, just like the way Mushin said, by scientists and technologies and these NGOs working together.
Okay, thank you. Maheshwar or Mark, would you like to add something to this?
Yeah, I'd just like to add one, practical experience. We're in Nepal. We have cookstove demands from several different altitudes, and there are some quite good or not so good examples that cookstoves have been used at certain altitude where they're not supposed to use. Demand has been higher in that area. So, as an atmospheric scientist, if you can test certain types of, cookstove at different altitudes and say, how much emission would be for different types of, fuel use, I think that would help the designers to design those cookstove for, different specific conditions.
Maybe I can pick up on the question that Dean raised, which was an interesting one. What are the goals that climate folks want us to achieve? And I'd say actually there might be a little bit of a disconnect in the communication when we bring up questions like this, and I think that it's a lot of that lies on the side of the climate change science community in the way that they communicate their results and the implications of the results. But I think the only goal that I would want you to achieve in the big picture is to help to reduce the suffering of people that are living there, and to make use of whatever information you can from us, or tell us what information that you need to help feed into that big overarching goal. We can certainly provide information about what kind of particle characteristics would help to reduce the impacts on the climate, and what kind of particle characteristics would help reduce the impacts on health. But I don't think it's up to us as scientists to lay out goals and say, you have to get the single scattering albedo above 0.9 so that we get the temperature goal that we've set out, that actually policymakers have set out. So thank you very much for asking that, Dean, but I would turn it around and say, whenever you can come up with information that would be useful for you, then pass it back to scientists like Maheswar and Ramanathan and me, and we can iterate on how we can best provide you with that kind of information to achieve your goals.
That's a wonderful answer, and that we all share, first and foremost, that's the goal, right, is that the woman is smiling when she's using the new stove, and that the whole environment of the house has been improved so that the family is experiencing a better life.
Okay, thank you, Dean and Mark, for this. I would like to close with a final question, and would like each of the panelists to just give a short statement. So the question would be, based on the discussion we just had, from your point of view, what is particularly useful for upcoming scientific investigations, for policy recommendations, and also for non-profit and private efforts to design cookstoves and to disseminate them? And maybe somebody wants to go first?
I probably have the shortest answer, so.
Okay, then Mark, go ahead.
So since I probably have the least of the experience of this and can give the shortest answer, I think it's really important that scientists get in on the ground floor, get in the field, and I know that all of us are involved in it in some way. We have a campaign going on in Kathmandu Valley very soon, and we're going out to Nepal and spending more time out there. Ramanathan spends quite a bit of time in the field, and picking up on what Dean and I were just talking about, that we get the exchange of information and the information flow going so that it can optimally support the work on the ground that really needs to be done.
Okay, thank you, Mark. Maheshwar, do you want to address maybe your field campaign that's coming up?
Sure. Yeah, before I move to the field campaign, which is part of the bigger picture that I'm going to talk first, basically one business model doesn't fit everywhere. So what we need to do is, again, I'll emphasize the 6 points that I mentioned earlier. There are 6 issues. If we, as a scientist or social scientist or Cookstove designer, if we get involved together and at least do a couple of pilot studies where these 6 issues will be customized for the local need, I think that business model will be successful for that particular context. And going to the campaign, definitely, understanding the science first, getting it right before we move on to the mitigation is the foremost important thing. That's what we are trying to do in Kathmandu. For example, looking at what source is contributing how much, and that will give us, quite good scientific foundation for the mitigation. So, how much percentage is coming from Cookstove versus traffic and, other sources. So we don't have that information in many places at the local context. So, having such information will help us design the mitigation measures, including the Cookstove.
First, I wanted to thank Yulia and I think probably Jessica Wallach, who helped initiate this discussion. And we talked about the Global Alliance, and I wanted to talk about one more positive development just this year, is there is a new coalition has been formed, Climate and Clean Air Coalition. And this was initiated by Sweden, US, Bangladesh, and several countries now, and it's under the UNEP umbrella. And because of the cook stove issue cuts across both health on the one hand and climate change on the other hand, particularly regional climate change. So this coalition is also become interested. So in a sense, this sort of exchange, which was organized by this institute between those who are working on climate and air pollution and the cook stoves, is very important. Hopefully next time we'll also have some health experts to complete the picture. Thank you.
Okay, thank you very much. Mushin, may I ask you for your final comment? Mushin, can you hear us?
Julia, I'm having hard time to hear the last 5 minutes. Oh. Did you ask me for my last comment?
Yes. It would be.
I would say in the context of, from my perspective, we need science, we need researchers. So please come ask us what we need. I think working together, we'll be working on real problems that will help science and will help make a real product, practical product.
Okay. Thank you. Just to summarize again, so Mushin is saying that it's very, very important to intensify the communication between the scientists and the cook stove designers to come to a more comprehensive solution in that question. And Dean, may I ask for your recommendations that are helpful in upcoming efforts regarding science, also policy recommendations or non-profit or private efforts?
I would pick up on your last thought there that I'm hoping that we move towards a business commercial solution, which is going to be based on a lot of hard work, doing pilot studies, figuring out what in reality addresses all of these problems, and not to go over it again too many times, but as we were saying, problem number one is that the woman is smiling, and that the family is happy. And that's what makes this such an interesting problem. It's not just an engineering problem; it's a human problem, and that as we gain experience through testing, studying, that the manufacturing side, the distribution side, the whole business side of this is, I hope, going to be a big help in hitting a large middle segment of biomass users with available options, just as in many ways other interesting options have been become available. So I think don't forget business. That's an important part of the solution.
Okay, thank you. Would anyone like to add anything to this? No. Okay. Then I would like to close this session and thank everyone for being on the panel and also for joining us in the audience, live audience, and diverse virtual audiences. And I think we've spoken and addressed a lot of different topics here. And I will try to give a very, very brief resume. So as Dean pointed out, we have spoken about a problem that has a very, very important human dimension. It's not a business problem only, and it's not a technical problem only. So this is very important to keep in mind. And then also important is to make the cookstoves affordable, help with microfinancing, for example, and also very important, involve the stakeholders, involve the users, and start communicating more intensely across the different sectors, from research, climate research, atmospheric research, also health research, and then involving the designers and involving those who will disseminate the cookstoves. And there is a global alliance for clean cookstoves and the Climate and Clean Air Coalition. And if we all work together, maybe we can overcome the remaining challenges as technology or technological problems are solved to a large extent, and work on the quick dissemination of cleaner cookstoves in the near future. And overall, the most important goal is to lower the suffering of people and make them smile, as Dean and Mark were saying several times. Okay, and last I would like to mention that this seminar was recorded. You will find the recording on the webpage, and there will also be follow-up information. And if you have further questions, please send us an email or keep typing in the chat box, and we will try to get to this. Thank you very much.